We're talking about hundreds of billions of pounds of animal meat that are eaten by people all over the world every year. So we have to develop manufacturing systems that can meet that demand, because there's so much of it. That is a challenge, and it's a challenge that many disruptive industries are facing, such as the electric car industry and other green industries. It's in order to actually transition into these more environmentally sustainable models of production, we have to build new systems.
Hey everyone, in today's video we're going to go through a excellent talk by Jess Krieger. She is the founder and CEO of Ohayo Valley. They are a cultivated meat company, portfolio company of Cultivated Science. Right now, their first product is to be wagu beef. And what I love about this talk is it really goes into a lot of technical details about some of the challenges that are facing the cultivated meat industry. One of the things I've seen a number of people get confused by is just the technology in general, because the technology, again, came from cell culture, came from the medical industry. And when you look at it at its face value, it doesn't look like it's possible. But this talk gets into the actual engineering for how a lot of this technology can be used in food applications. With all of that, let's get into the video.
I want to thank everyone for joining. And I think, I see people joining us as we go. I'm just going to say a couple words in introduction. On behalf of the CCC and the UCSF LaunchPad, we want to welcome Jess Krieger to this Fireside chat. And just as a couple words of background, the CCC is an NSF Science and Technology Center, and it's focused on turning the discipline of cell biology into an engineering discipline. It's really fascinating. It's a partnership between UCSF, UC Berkeley, San Francisco State, the Exploratorium, Stanford University, and the IBM Almaden Research Center. The UCSF LaunchPad is focused on promoting student entrepreneurship, and it's supported by the Blackstone Foundation. And so again, I want to thank you very much, Jess, for joining us tonight. We really look forward to hearing about Ohayo Valley, the cultured beef company that you founded and are the CEO of, which is housed over in the new Baker Bioingenuity labs right next to the UC Berkeley campus. One of my favorite buildings, an old art museum. And so, Jess, how about if we start, with your own entrepreneurial journey? Because I know that you actually crafted a novel PhD curriculum for yourself. And as well, Ohayo Valley is the second alternative meat company that you founded. And so take it away, Jess.
Well, thank you so much for the introduction to speak with this group today. I'm very excited about the CCC and the potential that cell modeling has in the cultivated meat industry. So great to speak with all of you today. My entrepreneurial journey started because I knew that I was going to have to commercialize cultivated meat products. My journey begins 12 years ago. And at that time, I was an undergraduate studying neuroscience, and I discovered the environmental impact of animal agriculture. And I knew that the demand for animal meat was only going to increase and actually double by 2050. So if we increase the supply of meat to meet the demand, we're headed towards an environmental catastrophe. And back then, 12 years ago, plant-based meat was not super great. We have come a long way in terms of the quality of meat alternatives, but we are not all the way there yet. And I knew from my own experiences trying meat alternatives that the quality is not convincing. It's not convincing enough to really change consumer purchase behavior and how people incorporate meat into their diets. So I decided to think creatively about a solution for how we can develop these meat alternatives. And there were ideas out there already. I wasn't the first person in the world to think that cultivated meat is a solution, but in my own personal journey, I thought of it independently, and I thought, okay, if plant-based meat and other types of meat alternatives are not going to work to change people's diets, then we need a substitute that's going to completely recreate the experience of meat from animals.
Just an aside, I've spent a lot of time recently trying as many different plant-based meat products as I can, and I'm honestly not very impressed. I thought it would be better by now. Version 1, let's call it, it's just using too many starches and too many ingredients that we need taste, texture, cost are kind of the three main things. It's gotten a lot better with the Impossible and the Beyond Meat. I think that really brought this into the limelight for a lot of people, but still the average plant-based meat I don't think is that great. And so I'm going to call that version 1. And then I'm going to call the Impossible Burger and the Beyond Burger version 2. I think we're getting to version 3, which is going to get better. So we are getting better in the plant-based meat. That said, it's still not quite there. And we need as many different options as we can until someone gets there with some kind of product.
So I thought cell culture technology is actually a way to do that. And at my university, we were doing cell culture and skeletal muscle cell culture. And I thought, okay, this is the way forward. We can grow cells outside of the animal and develop meat products that way. And I've tried numerous cultivated meat product prototypes since then, and the cells really do taste like animal meat. They have the same protein, they have the same fat as what you would find in meat from animals, and it's the missing link, I guess I would say, between where we currently are in the quality of meat alternatives and where we're going to be in the future, because we can actually create products that taste exactly like animal meat and have the texture and the mouthfeel of animal meat. So there was nothing happening in the world back then when it comes to cultivated meat science or companies that were focused on the space. So this was back in 2010. I would say the cultivated meat industry really nucleated a couple years after the world's first lab-grown beef burger was introduced to the world. And that was Dr. Mark Post, who introduced the world to this new type of food. That was in 2013. But the industry, it took a couple years to take off, and it really took off in 2016. So I started a PhD program to focus on actually a regenerative medicine project where I was developing tissue engineered skeletal muscle constructs. And that was my PhD project. I was accepted into graduate school to focus on this PhD project the same year that Mark Post came out with the world famous lab-grown beef burger. So my experience throughout graduate school, like Charles said, there were really no resources back then. There was no funding to produce or to pursue cultivated meat research. And there were no companies yet back in this space in 2013. So since I didn't have any actual resources in terms of the cultivated meat industry, they haven't been created yet, I thought if I nest myself in the regenerative medicine industry and I focus on kind of a parallel type of technology, which is skeletal muscle tissue engineering using culture systems for skeletal muscle cells, then I can learn the technology principles to transfer all of those principles over to cultivated meat. So that's exactly what I did. So for the first 3 years or so of my journey in graduate school, I was focused on regenerative medicine research. And 3 years in, it was 2016, around 2016, the world's first cellular agriculture conference took place in San Francisco. That was an organization called New Harvest that hosted that conference. Cellular agriculture refers to more than just cultivated meat. It also refers to types of production systems that are cell-based. So cells produce the products, but they're products that normally come from animals. So it can be agricultural products that come from collagen from the animals, that can come from meat from the animals, but we're just using cell culture to produce these products in a different way.
Gelotech would be an example for this, where they use cells to produce the collagen.
So I went to that conference and I actually obtained PhD funding from New Harvest, and they were the first group in the world to financially support and give grants and sponsor PhD fellowships in cultivated meat specifically. So I got very lucky in terms of I had already prepared myself a bit and I had already learned about many of the types of technology involved in cultivated meat in the regenerative medicine industry. And then when I met New Harvest, that was really the I guess the inflection point for my career where I could actually really exclusively focus on cultivated meat. But I knew that in the long run I was going to have to start companies, because building the technology is only one half of the solution. We then have to scale it globally in the global meat market, so we can actually make a difference in how meat is produced and reduce the environmental impact of meat. So the goal was always to start companies, and start a company. I didn't anticipate starting 2 companies, but here I'm on my second one. So during my PhD program, I had met my co-founder for my first company, which was Artemis Foods, and I ended up starting that company with him, focused on developing cultivated ground beef products. I don't recommend trying to start a company while you're finishing your PhD. Somehow I did it, but I was very stressed out and it was a hard time. But I ended up leaving that company to start Ohayo Valley, where we're focused on cultivated steak and more broadly cultivated beef, because it's the most environmentally taxing form of meat that's out there. But now I have the experience of developing a full spectrum of beef products, whether they're cultivated ground beef or they're whole cut steaks. So we're at Baker Labs now. We're still a small team, but we're developing different types of beef products. And I decided to focus on Wagyu in particular because there were a couple reasons. The first is that marbled steak is the holy grail of cultivated meat. When we have a deliciously marbled steak, then I think we have really cracked the meat innovation in that way. So it's the holy grail, and also it's a very complex product, which is why no one has really convincingly achieved it yet. So because it was so complex, I wanted to figure out how to make it, because once I figured that out, then I could create any type of meat product. So we developed a process for producing cultivated whole cuts that can produce Wagyu steak, but ultimately can be customized for any type of meat. So we could use this same technique to produce chicken breast or bacon, It's not limited to steak. It's also the world's most scalable method of producing meat alternatives. So we are at the beginning of an inflection point for my company, Ohayo Valley. We have lots of fun adventures ahead of us, and my entrepreneurial journey is definitely not over. It has just begun.
From my own personal experience, it's amazing when I go into a grocery store now, the number of aisles, well, the number of shelves and freezers and refrigerators that have alternative meat in them. It's mostly plant-based, but this Impossible, Beyond Meat and Impossible Burgers, I mean, they've completely taken off and they're not dominating, obviously, by any means, but in the case of cultured beef, cultured beef that you're trying, do you see some hurdles, or what do you see the industry needs to do to be accepting of cultured beef versus plant-based beef? Or do you think there's this momentum, analogous to, self-driving cars, that's just unstoppable? And given the climate impacts, as you mentioned, that it's going to be here and you're going to be at the front of it? Or what do you see the challenges are?
I would say that there are currently a lot of challenges when it comes to bringing cultivated meat to market. There's certainly the technical challenges, right? So we have to lower the cost of cultivated meat production, but and also on the consumer perception side, there has to be a lot of education with consumers about what they're eating and why they're eating it, and why it's important to look for meat substitutes versus eating regular animal meat because of environmental issues. I think probably what most people have not been exposed to, if they are not focused on climate research, is what the world is going to look like 5 years from now, 10 years from now, 15, 20 years from now. The way that the animal agriculture, in the industrialized animal agriculture industry currently exists, is going to be completely disrupted by climate change. So especially when it comes to beef, there's so much animal feed that is used to develop beef products. I think the conversion of plant protein to beef protein is something like 25 pounds of plant protein to 1 pound of beef protein. So there's so much food that is fed to the animals that actually could be fed to humans.
The inefficiency of an animal as a food production system just blows my mind. It's so inefficient and it's so bad, but we eat it because it tastes good.
This animal feed, things like soy, this is going to become harder to produce, and it's because of climate change. So farming is changing all around the world, and it's changing the supply of farmed produce, the availability, and the cost. And all of those factors are going to increase the price of meat over time, increase the price of animal meat. Additionally, the climate is just going to become inhabitable in a lot of places for the animals that are in the industrialized industry. This is morbid, but a couple of months ago, there was an instance, I think in Kansas, where, maybe 10,000 heads of cattle, they passed because of heat stroke.
Shocking videos like this spread like wildfire Wednesday, claiming a heat wave killed these cattle in southwest Kansas. And headlines like this claimed more than 10,000 head died. It left many people wondering if it's even real.
I have seen some of the videos around, and it's certainly not something that you ever want to see or something that you ever want to deal with.
Turns out it is real.
And these are extreme climate events that are not, they do not fit into the current paradigm of how animal agriculture is going to work. So there are technical hurdles, and there are consumer perception hurdles and regulatory hurdles and scaling hurdles. All of that exists. But in the future, in the coming years, there's going to be a massive amount of momentum behind meat alternatives, because the price of animal meat is just going to become so high that people won't be able to afford it.
Beef isn't the only thing that's getting more expensive. If you're in Canada, you'll have seen chicken prices skyrocket earlier in 2023. And in the United States, you'll have seen egg prices skyrocket because of bird flu outbreak also earlier this year.
So that's unfortunate that food is going to become more scarce, but that's why Ohio Valley is doing what we're doing, so we can still feed the world despite the world changing.
I think we'll turn to Professor Deneclaw, who has his hand up.
Very interesting talk. Thank you. I come from a ranching family, so I was raised raising livestock. My brother's a part of the New Mexico Livestock Board currently, and so I'm kind of wondering about how the industry, this cultivated meat industry versus the traditional beef industry, are going to work together and not be adversarial in that sense, because I think that that's the way I see this market, where you're not looking, where there's not a good relationship yet established on, the two industries as a way to provide this important resource for everybody across the world, to have meat available. And so I'm just wondering what your thoughts are on that.
I have my own perspective. It's not necessarily shared by everyone in the industry, but I firmly believe that the relationship between the cultivated meat industry and the traditional animal agriculture industry, this is a relationship that can work together. Mm-hmm. Granted, disruption is coming to the animal agriculture industry and for cattle ranchers, but there's also new ways to do things and new ways to find opportunities to work together and still feed people and make money together. So in my quest to develop cell lines, I've worked with a number of cattle ranchers, actually, and different kinds of farms and farmers who had different animals. And we compensated them financially for taking tissue biopsies from their animals. I mean, we still need animals in order to produce cultivated meat because that's where the cells come from. So I think we were paying around $1,000 to a farmer per tissue biopsy from one of their animals. And so that farmer, at the end of the day, we took 7 biopsies, and that farmer cashed out for $7,000. And that's much more money than one will usually make from one cow, from one head of cattle.
Still has a cow.
Yeah, exactly. So there's actually a great financial opportunity there. I think what needs to happen is the global herd size of cows has to decrease because it's too much on the environment. But I think having smaller farms with smaller herds of cattle is still completely within the vision of agriculture that I have for the future, and is part of a partnership between the people who have the animals and the cultivated meat industry to support each other and the planet.
So my other question was, you mentioned different kinds. So is there a difference in the flavor from the different kinds of cattle, the different breeds of cattle that you're getting tissue samples from? Is there a quality difference in terms of the flavor and all of that?
Yes. So we are focused on developing wagu, and this is a type of meat that has different, much higher amount of marbling than other types of steak, such as different breeds of cattle in the United States. So we basically want to recreate the protein and the fat profile of different types of meat, such as wagu versus another type of breed. And through these different breeds, they have different protein and fat profiles in different muscles among different breeds. For example, Wagyu, A5 grade Wagyu in the United States and in Japan has over 50% intramuscular fat. So it's more than 50% marbling compared to the amount of skeletal muscle that's in the product. So when we're designing cultivated meat products, we want to recreate that protein profile, that fat profile, to make it taste like the type of meat that we are recreating. So yes, the different cattle breeds have, I would say their cells behave slightly differently and can give different flavor profiles. But one of the goals of cultivated meat research more broadly is to identify how we can improve differentiation between products and improve the sensory quality and really customize that sensory quality to match the type of meat that we're substituting for.
Thank you.
Thank you. Larry, how about you with your question, please? There you go.
Thank you. Jess, thanks for coming. First, I agree with the mission completely, but assuming that consumers will accept it, assuming all the technical hurdles can be met. So where are the real barriers to lowering the cost? And it's not going to be scale, and it's not going to be waiting for the price of real meat to go up, because then consumers won't be able to afford either. So could you speak to that a little bit?
Yes, I would say that there's two main cost drivers that I think need to be overcome in order to make this a commercially viable industry. The first is the cost of the feedstocks that go into the cultivated meat bioprocess. So this involves the cost of media, cell culture media that goes into the cultivated meat bioprocess. And other types of ingredients that are required. So typically, since this technology was developed so bioprocess and bioreactors, this kind of technology has been pioneered in the biopharma industry. And health-related products, medical products, have a much higher, they have a bigger profit margin than commodity meat products. So while the technology for growing cultivated meat originated in the biopharma industry and the pharmaceutical industry in general, we have to lower all of those costs, which were originally not optimized for a product that's $5 per pound at the market.
This is important to understand. Because this technology was originally used in the healthcare industry, it's designed for health purposes. And ultimately, I would suspect that most of these technologies, while the base idea of cell culture can be used in both industries, we would need to reinvent most of the technology in order to actually make it applicable to the food industry.
So we have to do we have to pay great attention to the costs that go into the process. And at Ohayo Valley, we've pioneered a process where we are actually lowering the cost of media and lowering the cost of the feedstocks that go into the cultivated meat bioprocess by essentially creating a collaborator called it the other day like skinny cells. So skinny cells that need less proteins, that need less ingredients in the media to support their growth and survival. Basically creating a cell line that's much more evolutionarily fit and doesn't require as many proteins in the media, and making the cell lines more independent than in their growth process and less reliant on external factors to support their growth.
I'm really curious about this. Like, would the cells themselves need 50% less food to grow? Something interesting to think about.
And by doing that, you can greatly decrease the cost of cultivated meat production. And we recently did an experiment where we had dramatically reduced the cost of media for the cells by using a cell engineering approach. And that's one of the interesting parts about the CCC is there's this focus on using cells as bioreactor systems. And that's exactly what the way that we approach cell line engineering is. We think about the cells as a bioreactor, and how do we get the cells to perform in the way that we want them to, and lower the cost of manufacturing as well. So there's a very clear path forward in terms of using cell line engineering to decrease the cost of cultivated meat. And I would say the other major technical hurdle would be just scaling the industry when it comes to producing enough steel or producing enough materials to make the bioreactors and make the bioprocess themselves, because we're talking about hundreds of billions of pounds of animal meat that are eaten by people all over the world every year. So we have to develop manufacturing systems that can meet that demand, because there's so much of it. That is a challenge, and it's a challenge that many disruptive industries are facing, such as the electric car industry and other green industries. It's in order to actually transition into these more environmentally sustainable models of production, we have to build new systems. So that is going to be a challenge, but it's a challenge for any disruptive technology that we see in the market today. But there is room for innovation. And I think that innovating along the lines of bioreactor design and finding cheaper materials that you can use for bioreactors than what are currently used is another way to really drive down costs and increase the scale of manufacturing systems that will manufacture cultivated meat.
Thank you.
Thanks, Larry. Jess, actually, I have a technical question, I think. And you mentioned how your first company was focused on ground beef. And, when you're at the store and you're looking at a rack of different hamburgers, there is some variation. But you mentioned bacon, my question is this, is when you think about bacon or a high grade steak, like a wagu steak, I'm not sure how to say this, but it's like heterogeneous homogeneity, or it's the opposite. It's homogeneous heterogeneity, and that you have these steak specific textures, but you can tell it's a New York, you can tell it's a wagu or something, but then no one is exactly the same. And so how can you create at the granular, I guess it's like at the scale of tissue, cellular tissue diversity, such that it looks like a piece of bacon, or it looks like a steak, that are so canonical. I mean, you can put a piece of bacon, you can turn it into a Bitmoji little internet icon really easily. But when you're at the store and they have like 6 different kinds of bacon, your eye can kind of like distinguish one from the other. So how do you achieve that granularity of macroscopic texture that our eyes look at and decide whether to buy it or not?
That's a great question. And we approach this technical challenge by using a material science approach. So we're not necessarily tissue engineering meat. We're not necessarily and tissue engineering and bioprinting cultivated meat is. I don't think that it's a commercially viable and economically viable way of producing meat, just because it's very expensive, very complex. I think the way that we create cultivated meat whole cuts will be different than how engineered tissues for regenerative medicine are produced, because it's just there's completely different needs for both products. One is just really a sensory experience and a nutritional experience, and then the other is obviously some sort of medical treatment for a disease, and those are two different processes. So in knowing that, I've decided to use a material science approach instead of a tissue engineering approach to developing cultivated meat products. So with the process that we created, it's a blend of cultivated meat and plant-based meat together, where essentially we develop a plant-based meat product that has the taste and the texture, bite, mouth feel of meat from animals, but then it's essentially spiked with animal cells that will give it the meat-like flavor, which is where plant-based meat is currently pretty limited.
Remember in the video with Eat Just how we were talking about the 75% law in Singapore, where 75% of the product has to be cultivated meat? Well, what if we don't need that? So this is the thing with regulations. Until we can actually build the product and get it to work, it's kind of pretty arbitrary. Like, what if the actual product at the end that tastes identical to a Wagyu steak is 90%, 95%, 99% plant-based ingredients, and the 5, 10, 1%, however many percent it is animal cells? That would also drastically reduce the costs and the complexity of the product and the production costs. It would mean we could get to market so much faster with a product that is on parity or significantly better than traditional meat that we eat today.
So with the process that we're using, at scale, we can customize the products in a way that has never been possible with the traditional breeding system that animal agriculture has used to optimize flavor characteristics of the meat and production yields. So creating meat products from scratch actually provides this opportunity for customization, because you don't have to rely on the genetics and the biology of an animal to create the products that you want. So by blending plant-based meat and cultivated meat together, we can create a manufacturing process that allows us to customize the properties. So for example, for a Wagyu steak, we would add more fat to the product because there's more fat in high quality Wagyu steak products. For a more commodity type steak product, we wouldn't have to add as much fat. And we can also change the structural characteristics of the product as well to customize it so it has this less fat content and less marbling structure between all of the skeletal muscle structures. And in that way, biomanufacturing meat actually is the key to endless customization for different types of meat products. If you just think about how many different types of plastic products we can produce, and the great variability in the types of plastic, the purposes of the plastics, such as engineering plastics versus commodity plastics, like just plastic wrapping for something you get from the store, we'll be able to customize all of that. through our process. And beyond that, we're going to be able to develop products that have never existed before. Granted, I think we need some time to accept completely new products that have never existed before. But this is really, it gives us an opportunity to further tailor and customize the food system by no longer being limited to the biology of the animal.
Got it. Slightly related to that, I'm thinking of, when you see Wagyu steak on a menu, it tends to be sort of an expensive place. And when you mentioned electric cars, and obviously the first people, these early adopters, a lot of them were driven by the, let's say, environmental impact of fossil fuel cars, and they wanted to, not make a statement, but they wanted to do something for themselves. I mean, they wanted, yeah, you know what I mean. They wanted to sort of like say, I'm driving an electric car because everyone sees, what car you're driving on the road. And so is there a strategy? Do you have a strategy is that one of the reasons you picked, an extremely expensive steak and not hamburger? Because if you get one steak on a menu that has 19 other beef, animal steaks, a lot of people will pick yours just because of what it signifies. So what is that how you're going to try to crack into the world, is start with rich people that can afford expensive food and then sort of trickle down to the rest of us?
There's a couple reasons why we decided to focus on Wagyu, and one of them was definitely the financial aspect. So in the United States, the price per pound for A5 grade Wagyu is $83 per pound. So in our manufacturing modeling, our financial modeling for how much it's going to cost to produce the cells for this product, we can actually still make a profit with such an expensive product. For our calculations, we'll be able to make in the beginning about $50 of profit from per pound from an $83 per pound animal Wagyu equivalent.
That means they have production costs at $30 per pound, which is significantly lower than what others in industry are quoting, which is around $100 or under sub $100.
I would say the ways that we actually do have a similar model to Tesla is actually with the branding and the marketing, and producing a very high quality, very decadent, luxurious product that has very high quality sensory characteristics is important to get people excited about this new type of meat alternative. It's also important to show people that you don't have to decrease the quality of your life and the quality of your life experiences to incorporate meat alternatives into your diet. In fact, you can have even better life experiences if you try cultivated meat. But then on a more personal level, I wanted to focus on Wagyu because it's quite technically complex. And I knew if I could crack that, then I could crack any type of whole cut.
Oh, wow. I see we have a question from Lauren. Lauren, how about if you ask it?
Thanks so much. Hi.
Hi.
This has been a great talk. I've really enjoyed this. Personally, it's very exciting to me because I don't eat red meat anymore, and for environmental reasons and ethical reasons. And so I'm very excited about this launching. I'm not sure what your timeline is like, but do you already have some buy-in from restaurants that are interested to use this in their menu?
Yes, actually, we did a survey of all of the Japanese Wagyu steak restaurants in the Bay Area. and most of them were incredibly excited about this product. It's so there is, even among the I would say the premium luxury types of meat, people are very interested in it. Consistently, about 33% of Americans really do want to replace animal meat with cultivated meat, as long as the sensory experience is the same. So there's a lot of interest, a lot of demand, and at least I know the Bay Area is its own, micro culture, and it's not the same everywhere, but there's definitely interest and demand here.
Great, thanks. And I'll just put a plug. There are a couple questions in the chat too. Thank you.
Professor Aris Mattis at UCSF, he's got a cool question. In fact, Aris, if you can hear me, how about if you just ask it?
Sure, thanks. This is a really great talk, and I'm in the regenerative medicine here at UCSF, so I've always been fascinated that you could try to make meat. But I guess I'm curious, like, if you cut tissue sections, of your product and you compare it to your Wagyu under the microscope, I mean, does it look the same? I'm just curious about that. I mean, I know the taste, I know that taste could be developed, but does it look the same? Like, I don't remember if you mentioned, protein content or fat content, at which point, I guess, does it, and maybe I had to step away for a minute, so I hope I'm not repeating something. At which point is it that a vegetarian would say, yeah, this cellular product is not, is more like a vegetarian product, but what separates it?
That's a great question, and that's an area where there's going to be a tremendous amount of innovation in the alternative protein industry. I think that there's a way to get I would say the macro structure of meat correct without having to completely recreate the native tissue environment that you would see in skeletal muscle tissue in vivo. So with the process that we've created, we can produce cultivated meat that has aligned proteins, the way that you would see in traditional animal meat, and traditional skeletal muscle tissue, and then cells and marbling that are interspersed between those aligned protein fibers. So these structurally, we have the ability to create similar structures. Does that translate into a tissue that has the same extracellular matrix content and the myotube structure and other structures of the cells and tissues? I don't think we necessarily need to 100% recreate the tissue, because at the end of the day, we're just talking about a sensory experience that you're eating. And that's going to be the defining factor for the success, besides the economic viability and the technical hurdles behind cultivated meat. That's going to be the defining characteristic of whether or not people are interested in these products, because it just comes down to the sensory experience. So because these products don't have to perform and function as viable tissues, we have flexibility and room to innovate, so we can get the same kind of material experience and sensory experience without having to completely recreate that tissue, that native skeletal muscle tissue niche. Does that make sense?
Yeah, no, absolutely. Thank you for that.
Thanks, Aris. I see Wilford has another question for you, Jess. Go for it, Wilford.
Hi again. Yeah, well, that's really interesting, and I'm trying to understand the mechanism of how all of this works in that sense. And you've got muscle, the satellite cells. You have to activate them. Are you using just a natural activation, and are you culturing them with growth factors or with serum, fetal bovine serum, or something like that? I mean, in other words, what are the external factors that you are applying so you can acquire your proliferation and eventual expansion of these cells? How does that impact the quality of the product you're trying to raise?
Well, the general process for creating a cultivated meat bioprocess involves cell line development, and that would be skeletal muscle cells, fat cells that can recreate the flavor experience of meat. So you have cell line development, and then a expansion of those cell lines in bioreactors. And then there's a specific media formulation that's used to grow the cells in the bioreactors. And as I mentioned before, Ohio Valley is using a technical strategy where we're lowering the cost of the media through cell engineering methods. So that there's media that goes into the bioprocess, and then cells can be collected at the end of that bioprocess and used as a raw material to add to plant-based meat products to make blended cultivated meat products. So essentially, I would say it's very much a similar process to what the cell therapy industry is using, because the cell therapy industry is not necessarily tissue engineering tissue engineering different medical products. They're creating cell products that can be used to treat people in various medical conditions. So I would say it's more like for the entire process, it's more like the cell therapy industry. Although we have to really reduce costs and also come up with some novel instruments and equipment that are less expensive than what is used in the cell therapy industry.
You're not using basic growth factor, fibroblast growth factor, as a way to stimulate proliferation or other external factors like that?
Yes, and the recombinant proteins that are in the cell culture media are important signaling factors to get the cells to proliferate and grow, and also differentiate. But there's also opportunity to engineer the cells to not even need those recombinant proteins, which is how we're approaching reducing costs of cell culture media.
Thank you.
Thanks, Wilfred. I'll ask Jess if she has any last words of wisdom or thought or anything, but just on behalf of the CCC and behalf of the UCSF LaunchPad, I want to thank her for this thought-provoking presentation. And yeah, it really is, it's really amazing how fast things are changing and may change in the future. But I thought the point she made about global agriculture, meat-based, beef-based agriculture, pig-based agriculture, whatever you want to call it, it is pretty obvious that 100, it can't be the same 100 years from now. I think she might have even said 10 years from now. So, Jess, any last words from you?
I would say we are in a new era of the challenges that we're facing as people, as a civilization. I have my own, personal thoughts on life, and so I think that made me a bit different in the beginning to so stubbornly pursue solutions that never existed before. But I would highly encourage anyone who's inspired to work on climate technology, and who would like to apply themselves to developing disruptive industries that are more sustainable, to just find a way to do that. The world needs people who can apply themselves to helping other people and helping the environment and the state of the planet. if you can take those risks and if you are so inspired, I would highly encourage you to do that, because we need more people like that in the world to help us with the challenges that we're going to be facing in the future.
Great. What a great way to end it, Jess. And again, thank you very, very much. And thanks all of you for dialing in, zooming in, I guess. Okay. Bye-bye all. Thank you very much.
I hope you enjoyed that talk as much as I did. I'll see you in the next video.